All right, thank you, Gina, for the introduction. Hello, everyone. Good morning again. I'm Adili. This SonicSpray is a work by me and my colleague at University of Sussex, Diego Martinez-Plasencia, Gianluca Memoli, and Sriram Subramanian from the Interact Lab. And it's funded by EU, Ministry of Higher Education Malaysia and Technical University Malacca. So before I continue with my presentation, let me show you a quick about the SonicSpray in a video. Oops. Wait. Oops. Wait. Oh. Sorry about that. Okay, now. So it's a quick one, but it's to give you the idea about what is SonicSpray. It's a display, a permeable mid-air displays controlled by ultrasound. And when I call permeable display, means it can be reached through. You can see through it. So some examples like fog screens from work by Rakolainen. He also created and developed portable one, and Lam et al. Improve the depth of this screen by providing fog emitters in an array, and Lam also tried to reconfigure or reduce the mass emitters by using mechanical actuators, while Tokuda create more advanced fog screens, creating a curve like convex and concave using pipe controlled by also mechanical actuators, 5 of them, and also can adapt with a user doing some interaction. Now, the challenges are, they are all bulky. They might have a high price point because if you involve with the laser, for example, it's quite expensive. And it's very hard to reconfigure these aerosols in mid-air while retaining a laminarity of the flow. And also, it's difficult to get a very high resolution reconfiguration with a minimal form factor. So one possible solution would be work by Hasegawa, where they work direct aerosols to a user using a Bessel beam. But the problem is they found ghost in the work. What I mean ghost is like if he tried to steer the beam left or right at certain angle, let's say up to 20 degree, and he got opposite of it is like a replication of that beam, which will create a false beam. And the other one is the work didn't really explore, but is it laminar or not laminar, and how to reconfigure this laminar aerosol is also a question to us. Luckily, we've published a work and we have explored how to control a complex sound field we published at UIST 2018, and we really know how to reconfigure it, but we still have a few questions. For example, what is the minimum size of the phase array transducers for the aerosols to work as a display, and how to reconfigure this aerosol? We haven't tried yet for this SonicSpray. And then that's the flow laminar. So these few questions. Now this paper that we published will describe the minimum size required for transducers. We call it phase array transducers as PAT, and we'll describe how to modify it. and we'll verify the laminarity of the flow. So our insight on, we want to share the insight on the technique to reconfigure a laminar aerosols for mid-air displays through a smaller pad. So if this is a Bessel beam. If you can think about like transducers arranged in like a conical kind of shape. Now, if you cut a slice of X and Z plane, you can imagine like the sound source propagates this direction, while this transducers propagates on the other direction. When they meet at the center, they will create very high intensity, and this intensity will induce airflow going upwards. So we've done the 3D simulation of it. In A is the 16 times 16 array creating a Bessel beam. We've done a slice of X and Y plane. In B, we see a very high intensity in the middle, while C will show you all the sound pressure level of all from 16 times 16 to 2 times 2. Now, how we reconfigure this aerosol? So we have the pad, the phased delay given by the equation, if you don't want to think about the equation. Now we create the beam, for example, and we'll create a narrow kind of mist. We'll go upwards. Now, if we will control using a control point. Let's say the control point is P, where you can get there is like 00ZS. In this case, we try 60 mm. Now we want to shift it and create like delta XY. And this is the equation for it, which is psi. Now the final will be, the final phase delay will be phi with psi. So you will be able to shift it. Now, we've tried, we shift it in first row, we shift 5 mm of each, like A, B, C, and D, 5 mm, 10 mm, 15 mm. And we track the changes of sound pressure level at the second row. Quite good. We didn't see any ghost yet. But we have a problem here. Whenever we extend the shift from 20 mm to 35 mm, we see ghost. Also not good at the bottom, like the fourth row. Now we thinking about how about we try use metamaterials. Because this metamaterial have a very small size, is less than or half of the wavelength, which is really good. The problem with the Hasegawa is because the speaker, and also we're having the problem the speaker is quite large, bigger than the wavelength. This is the metamaterial. We have like 16 of them. Each of them introduce different phase delays. You can read through, more of paper. Now, let's say I have 35 mm. I introduce a Bessel beam by using the metamaterial. Now I will use phase array transducers to shift it. When I shift it, so the ghost gone. It will be gone. Now, we've tried. We have another problem. The response of the aerosol to the Bessel beam is poor. So we decided not to use the metamaterial. Otherwise, it will be very, very slow, and the display you cannot see clearly. And then we done some study on the laminarity. We found that all our transducer, like 2x2 until to 16x16, they have low number of Reynolds, and it's not turbulent, which is good. Then we studied that 6x6 transducers, array transducers, is enough for us to create the aerosols. But 4x4 is not enough to create the airflow. We compare the sound pressure level and the airflow speed only for 6x6, because this is the minimal transducers that we need. And interestingly, in B, you can see they have like similar pattern. We done a correlation between the sound pressure level and airflow speed got a very good correlation there. We can say that to increase the airflow speed, you can increase the sound pressure level. Next is we've done some evaluation to our SonicSpray. We capture a photo in long exposure of these steering the aerosol in lateral direction, and we say this is as we state this as a lateral resolution, and we change the frequency of this lateral resolution. So one complete resolution would be from 0 to 15 mm left and 0 to 15 mm right. We found that from 1 to 8 Hertz, it's decreasing gradually, but from 9 Hertz to the 25, it's constant. We cannot go beyond than that because it's constant, and we found out that the maximum we can go to lateral move the aerosols light up to 8 Hertz. And we also do lateral resolution by number of transducers, but the result is like not significant. Maybe we thought that we have low sound power. We might need to change the transducer with a higher sound power, let's say 20 volt, for example, and will increase the lateral resolution will be larger if you use higher sound power. So the application you can see from the video that we tried with the a game, for example, and some display in a 3D position where you see butterfly can move in 3D space, and also like a video conference. And we also state that this is not only for display, for visual display, but you can also extend it to, like, let's say in virtual reality, where you can use it for notification of temperature, like hot air, cold air. We can just direct it, because some of the work use a very bulky setup just to direct some hot air or cold air in their work. And also, SonicSpray can be used to improve the current fog screen, because if you see the current fog screen in B, at some point, at certain height, there will be a turbulent flow. But if we put SonicSpray, we can induce airflow at this region, at the turbulent flow region, to increase the height of the screen. And in case of mechanical actuators with fog screen, we can change the direction. We might have better control of the fog screen by applying SonicSpray onto these mechanical moved fog emitters. So as the takeaways, we reconfigured aerosol for display using only 6x6 pad, which is like 6x6 centimeter, while retain the laminar flow. And we provide significant benefits. For example, avoid enclosure, so you can reach through it, no problem, no noisy mechanical parts. And also we produce very precise control of the aerosol. Thank you. I am happy to take any question if there's any.
Thank you for interesting talk. And do you have any questions for him? We have about a couple of minutes. No questions from the floor? Could you kind of comment on kind of resolution that you can actually get from your SonicSpray?
Sorry, get what?
The resolution.
The resolution.
Yeah.
The resolution of the display we've tried is like 30 mm because you can go left on the left 15 mm and the right 15 mm. So in total 33 centimeter of display.
That's the current status.
Yeah, currently we can go that big, but it's not too big.
Okay, do you think it can be,
yeah,
improved,
if we
right?
can increase the sound power, we might be able to improve the resolution of the screen, and we also can improve the response rate of the aerosol, the particles, much more responsive, because at the moment it got like 30 milliseconds of response rate.
Okay. What do you think is the most, I guess, the potential application that you want to actually use this for?
Yeah, I've been thinking about not replacing but as an alternative to if you've seen this spinning display using LED, because you cannot touch it, but you can just mount it on the wall, and now user can see a 3D object on the wall, but it's very high up there. But if you can put it, user can touch and do some interaction with it. It's quite interesting because it's not dangerous at all. It's just a smoke.
Right. Okay.
Yeah.
Very good.
Good.
Any other questions? Okay. Yes.
Hello, Sun Jung Kim from Aalto University. One side effect may be that it increases the room humidity a lot, probably. So is there any alternative than the water mist?
Alternative than water mist?
What is the mist material are you using currently?
It's just like for fog screen. It's like I can't remember the name of it, but you can find it like vape, the liquid for vape pen. Electronic cigarette have this.
Yep.
Yeah.
Okay. Thanks.
Yeah.
Right. If you don't have any more questions, thank you again.
Thank you.
Let's give him a big hand.